Hi guys, today is May 22nd and we're going to be practicing solving trig equations, and we're just going to go over like 5 different techniques to look at a trig equation and kind of decide what to do, okay? All right, so let's just jump in and do this first one, okay? So we want to solve -2 cosine squared theta minus 5 is equal to -2 minus 6 cosine squared theta. So really all we have is numbers, right? And cosine squareds. So if I can get that cosine by itself, right, that one trig function, get it by itself, the square of it, right, I could just square root and I'd have an answer, okay? So let's go through and do that, okay? So I'm going to add 6 cosine squared theta to both sides, okay? So if I add that, that would give me 4 cosine squared theta minus 5 is equal to -2, okay? And then I'm going to add 5 to both sides. So that would give me 4 cosine squared theta is equal to 3, which then would give me, I'm going to divide both sides by 4, it would give me cosine squared theta is equal to 3/4, right? Okay, and then I'm going to square root both sides. Okay, so this gives me cosine, the absolute value of cosine theta is equal to, and then this would be the square root of 3 over 2. Okay, and because it's the absolute value, this could either be positive or negative, okay? So we have cosine theta is equal to plus or minus the square root of 3 over 2. Okay, so now we got to figure out, okay, so where's cosine positive, right? So cosine's positive in the first quadrant, right? And the fourth quadrant, right? So this would be square root of 3, and this would be 2, and this would be 2. This would happen to be 1, and this one would be -1. And then this angle would be pi over 6, because pi over 6 is always opposite 1. And this would also be pi over 6. And that's where cosine is positive, right? Whereas cosine negative? Well, it'd be in this third quadrant. So I'm going to draw one there, and I'm also going to draw one in the third quadrant, okay? So this one is where the horizontal leg is negative square root of 3. This would be 2, this would be 2, this would be 1, this would be -1. Again, the reference angle would be pi over 6, okay? And now we're gonna have our answers for theta, okay? So theta could be, because we're gonna only go from 0 to 2 pi, so it's gonna be pi over 6. That's one of our answers. This would be 6 pi over 6, gotta back up, so 5 pi over 6. 6 pi over 6, got to go one more, 7 pi over 6. And if this is 6 pi over 6 to right here, this would have to be 12 pi over 6, but that's too much. Back off, right? So that would be 11 pi over 6. All right, and there's our 4 answers. Okay, let's go to the next one. Okay, so this next one, there's a temptation to divide by cosine of theta, okay? And there's a problem with that. And the problem with that is you lose some of your answers that would work, okay? So instead, if you look at this and go, oh, divide both sides by cosine theta, right? Instead, move everything to one side because you're going to be able to factor out a cosine, okay? So what we want to do, since we have cosine theta and also cosine squared theta, we want to move everything. We want to make the cosine squared theta being positive, so we want to move it to the other side. So that would make 2 cosine squared theta, because I'd be adding it to both sides, plus the cosine theta is equal to 0, okay? And now we're going to use the zero product property because we can factor out a cosine theta. So cosine theta times, and then this one would be 2 cosine theta plus 1. And it's just a GCF, okay? So we have cosine theta equal to 0, and we also have 2 cosine theta plus 1 is equal to 0. So this one's ready to go. Okay, we need to do this one, right? So we need to subtract 1. So that would be 2 cosine theta equals -1, which would mean cosine theta would equal -1/2. Okay, so I'm going to draw a diagram for this one. Where would cosine be 0? Okay, that's where x would be 0, right? So x is 0 right here on the y-axis, on the positive y-axis, and also on the negative. So this would be, x would be 0, y would be 1, and r would equal 1. And down here, x would be 0, y would be -1, and r would be 1. And so our rotation from 0 to 2 pi would be here or here, right? Okay, so that would mean theta could either equal pi over 2 or 3 pi over 2. Okay, now let's do this one. Where's cosine -1/2? Well, cosine is going to be negative where the x's are negative, and that'd be these two quadrants. Okay, so I'm going to draw my triangle in there. So I know my x is -1. I know my r is 2 from this ratio. And I know this vertical leg, because of where they're located, this vertical leg would be the square root of 3. We have a right angle here. And this vertical leg would be negative square root of 3. So we're not opposite, this reference angle is not opposite 1 now, right? It's opposite square root of 3. That means it's pi over 3. And this is pi over 3. Okay, so here's 0 pi over 3. Here would be 3 pi over 3. So we got to back off, right? So another answer would be 2 pi over 3. And to get here, we need to go one more, so that'd be 4 pi over 3. And there's 4 answers to this. Now, let me tell you something. What would have happened if you divided by cosine theta, okay? We wouldn't have gotten these 2 answers, all right? And these 2 answers actually work. We would have only gotten those 2 answers. That's what would have happened, okay? So if you can't do this, okay? Because sometimes you can divide by cosine theta, okay? You can't divide and cancel on both sides, okay? That's when you lose your answers, okay? All right. If you only divide and it only cancels on one side, okay, then yeah, then you can do that, okay? Because you haven't changed it, you haven't lost it, okay? All right, let's go to the next example. Okay, this is a problem that I've seen a lot in calculus, okay? And a lot of kids don't know, they forget how to solve this, okay? Here's the problem. We have 2 different trig functions, right? Up to this point, we've all had the same type of trig function, okay? So a lot of times you're going to want to use some type of trig identity, okay? But we can't, okay? We can't, because we have just plain sine and plain cosine. So there's nothing that can switch it to sines and cosines, okay? Because that's usually what we would go to. But you can switch it to another trig function, okay? And here's how we're going to do it. So you look at this and go, okay, if I add sine theta and divide by cosine theta, sine theta over cosine theta will be a trig function, okay? So that's why I'm saying use a quotient identity, okay? So what we're going to need to do is add sine theta to both sides, and that would result in giving me square root of 3 cosine of theta is equal to sine of theta. Okay, so here's an example where we can divide both sides by cosine theta. It's only going to cancel on this one side, right? It's not going to cancel on both sides like the last problem, okay? So we can divide by it. We're not going to lose any answers, okay? Because the cosine theta is still going to be there. Okay, so we divide both sides by cosine theta. This left side is going to become the square root of 3. This right-hand side is going to become sine theta over cosine theta. And see, when we see sine theta over cosine theta, that's going to allow us to write it as one trig function, okay? So this is going to become tan theta, okay? So we have the square root of 3 is equal to tan of theta, okay? So I'm going to write it like this. Tan theta is equal to the square root of 3 over 1, okay? So my tan ratio is positive, and this is my ratio of y over x. Okay, so I know my y is square root of 3 and my x is 1, and I know that that can happen in the first quadrant. We should know that at least, okay? That's going to happen here in the first quadrant. So I know my y is the square root of 3, and I know my x is 1. When those are legs, the hypotenuse or radius has to be 2, okay? Now, is there any other combination of this where we could get a positive ratio here? And there is. If both of these are negative, right? If both of these are negative, that's going to make this positive ratio also. So we have to think of that, okay? And so that's going to happen in this third quadrant. Okay, so once again, my y, it's not going to be square root of 3, though. It's going to be negative square root of 3. And the horizontal leg here is not 1, but negative 1. And then negative divided by negative is going to give me this positive ratio. This would have to be 2, the radius or hypotenuse. And what's opposite the square root of 3? Well, it would be pi over 3 and pi over 3, right? And those are our only two choices. Okay, so that means theta would have to equal either pi over 3 or this would be 3 pi over 3, and we need to go one more pi over 3, so that would be 4 pi over 3. Okay, hopefully this is making sense. Okay, all right, let's go to the next one. So this next one, okay, what's difference between this one and the first one is that we have sine theta, right? We have sine squared theta, and then we also have this negative 1, okay? So that should be, we should be thinking, okay, we have like a squared term, a regular term, and then a constant, right? That's quadratic form, okay? When you see that, that's like x and x squared and plus a number, okay? All right, so what we're gonna do is we want this this is right now is 2 sine squared theta, right? I wanna keep it positive because it's easier to factor that way, okay? So I'm gonna move the sine theta over the left-hand side. So this is gonna be 0 is equal to, and I'm gonna write the squared term first. So 2 sine squared theta. Moving the sine theta over, I'm gonna have to subtract, so it's gonna be minus sine theta. And this negative 1 is still on the right-hand side, so it's going to be minus 1. Okay, so you can see the quadratic, right? This is like 2x squared minus x minus 1, okay? All right, so now we have to use an area model to factor this, okay? So we have to think of two numbers whose product is negative 2 and whose sum is negative 1. And that would have to be negative 2 and positive 1, right? So we're going to build our area model. Excuse me. Sorry, guys. Excuse me. Make this a little long because we're using trig functions. Because there's a lot more we have to write in the boxes. Okay, so this would be 2 sine squared theta. And this would be negative 1. And from knowing these two numbers, this would have to be negative 2 sine theta. Again, if you put this negative 2 sine theta down here and the one sine theta right here, that'd be fine. So this is 1 sine theta or just sine theta. GCF across the top here would be 2 sine theta, and then this would have to be sine theta, because these two would give you the 2 sine squared theta. This would have to be plus 1, and this would have to be minus 1, right? And negative 1 times positive 1 is the negative 1. Okay, so that gives us the factoring of this. So this would be 0 is equal to 2 sine theta plus 1. And sine theta minus 1. And those two things, when you multiply, would give you that original one. Okay, now what does this mean? We're going to use the zero product property. So either 2 sine theta plus 1 is equal to 0, or this one's the one that's 0, right? Sine theta minus 1 is equal to 0. This one, hopefully we can do this in our head, okay? Subtract 1 and divide by 2, right? So that'd be sine theta is equal to negative 1/2. And over here, sine theta is equal to 1. Okay, so where is sine negative? Okay, so sine's going to be negative in these bottom two. Okay, so I know my y from this ratio. I know my y's are both negative 1, and I know my r's are both 2. And knowing those locations, right, this would have to be the square root of 3, and this would have to be negative square root of 3. The angle of the triangle, which is the reference angle, would have to be pi over 6 and pi over 6. Okay, so that would mean our angle theta would have to equal, this would be 6 pi over 6, and we would need to go one more, right? So 7 pi over 6. This is 6 pi over 6, so we're going to go to here. That'd be 12 pi over 6, but I got to back up, so that'd be 11 pi over 6. Okay, and then we need to do sine of theta is equal to 1, right? That'd be 1 over 1. That's only going to happen right here. Okay, that's the only place where x would be 0, y would be 1, and r would be 1, right? It's that angle right there. And that angle is pi over 2. And there's 3 answers to this one, okay? All right, guys, that's quadratic form, okay? And let's go to the next one. Okay, so the next one, we're going to use a Pythagorean identity, okay? And if you look at this, we have 2 minus sine squared theta is equal to 3 cosine theta minus cosine squared theta, okay? All right. And there's no way that we could put these on one side and get sine squared theta plus cosine squared theta, okay? So what we're gonna have to do instead is, and then there's 2 options that we could do. Okay, so we could either switch out the sine squared theta or we could switch out the cosine squared theta. It wouldn't be good if we switched out the cosine squared theta. Why? Okay, cosine squared theta would be rewritten with sine squared, right? But we'd still have this cosine theta. And that wouldn't help us, okay? We need to get the same trig function, okay? Sine squared theta, we could write with cosine, right? So that's where we're gonna go, because then we'll just have cosines, the cosine theta function in our equation. Okay, so this sine squared theta, okay, is 2 minus, and sine squared theta is the same as 1 minus cosine squared theta. So I'm gonna replace this with 1 minus cosine squared theta, and then that would equal 3 cosine theta minus cosine squared theta. Okay, distributing this negative, we'd have 2 minus 1 plus a cosine squared theta, right? Is equal to 3 cosine theta minus cosine squared theta. Okay? All right, so now what I want to do is I could combine this. 2 minus 1 is 1, okay? And then I'm also going to add this cosine squared theta to both sides. So that'd be plus 2 cosine squared theta. And I'm going to move the 3 cosine theta over to the other side. So minus 3 cosine theta. Because what we're getting now is a Pythagorean, or not Pythagorean, it's in quadratic form now, right? But let's write it in the correct order. So this would be 2 cosine squared theta minus 3 cosine theta plus 1 is equal to 0. Okay? And so you look at this and go, okay, so this is quadratic form, right? Because we have a cosine squared, a cosine, and then a constant here, right? Okay, so we'd have to use the area model, because this is a 2. The coefficient of cosine squared theta is 2. We need to use the area model. So we need to find a product that is equal to 2 and a sum that's equal to -3. And so that would have to be -2 and -1. Okay, so again, we're going to need to draw a large or a long area model. Okay, so this would be 2 cosine squared theta. This would be plus 1. This we would have a -2 cosine theta. And here we'd have a cosine theta. Sorry, negative cosine theta. GCF across the top would be 2 cosine theta. Then this would have to be cosine theta. And then cosine theta times what would give you negative cosine theta would be -1. And then 2 cosine theta times what would give you -2 cosine theta, it'd be -1. And -1 times -1 is +1, so it checks out, right? Okay, so back over here, then that means this factors into 2 cosine theta minus 1 and cosine theta minus 1, and it equals 0. And I forgot the S and cosine right there. Okay, so that means 2 cosine theta minus 1 is equal to 0, or cosine theta minus 1 is equal to 0. Here, cosine theta would equal 1/2, and over here, cosine theta would equal 1. Okay, so we got to do 2 diagrams, one for this one and one for this one, right? Okay, I'm going to slide this up a little bit. Okay, so cosine theta, where's this ratio is positive, that's only going to happen when x is positive. So that would mean that we are either here in this first quadrant or we're here in the fourth quadrant, right? That's a bad rectangle or triangle. I keep calling them rectangles. Let me try to draw that straight. Okay, there we go. So this would be 1 all right? And this would be 2. And if that's 1, this would also be 2. This would be the square root of 3. This would be negative square root of 3. And then this angle would be pi over 3, and this angle would be pi over 3. Okay, so our answer to this one would be pi over 3. Okay, coming to right here, the negative x-axis, that'd be 3 pi over 3. Keep going, this would be 6 pi over 3, but I'd have to back off, so that'd be 5 pi over 3. Okay, and then where's cosine? And remember, this is equal to 1 over 1, right? I didn't write that either earlier when it was sine, okay? But where's cosine? Where is x and r? Both 1. Well, it would have to happen right here, right? Because right there, x is 1, y is 0, and r would be 1, and that would give you the ratio of 1 over 1, right? So that would be angle 0. And these don't have to be listed in any order, okay? So like they don't have to go from smallest to largest or anything like that, okay? All right, guys, that is the school year. All right, that's it. We're done. That's the last problem of Honors Math 3. Kind of sad. All right, you guys, through all of this, it has been an absolute joy to be your teacher. I just thank you so much for being in my class, okay? And I'm really looking forward to having a lot of you next year, okay? It's going to be fun. Hopefully we can get back to school, okay? Because I don't like teaching this way. All right, guys, let me get the assignment sheet, and I'll tell you what I want you to do. Okay, so what I want you to do is worksheet TEI 11. We went through all of these different techniques, okay? So today is 5/22, okay? All right, you guys, you take care. Have a wonderful summer. I'll be keeping in touch with you guys, okay? All right, you guys, you take care. Bye-bye.